Hello everyone, this is Ajay Kumar, Certified Application Engineer reference from AGS Computers. Today we are going to see a great topic about how to reduce manufacturing cost and design cycle time in sheet metal fabrication process. So today we are going to see a great time for how useful for sheet metal fabricators. Today's agenda we are going to see is some of the important topics about sheet metal and the normal industrial challenges. Industrial challenges commonly people used to face are the errors during the manufacturing and the calculation of the exact blank development area and the delay in releasing drawings, tedious to convert those drawings to the 3D CAD. So, crush those challenges and we will provide a great solutions through an innovative technology how to explore the sheet metal blank area and after the scrap reductions. So let me see one by one. What are the things we design? We can able to create a 3D model from the building block of sketch to the validation of my product, how it will be react in my real-time environment, and also how to create an error-free manufacturing drawings with representing to the normal standards like ISO, ANSI, etc. How to create an automated title block information so that the manual errors can be radically reduced so that the communications can be easily engaged between the designers and the software peoples. So let me design an objective of my today's goal is to create a gearbox cover for this type of model. Let me see how the tools are very much user friendly and how we can able to see create a sheet metal components with the representing to the flanges and the holes with respect to its thickness. So these are some kinds of productivity tools and some of the important tools that can engage the sheet metal designs. Let me see one by one. Normally I am just starting up with my convert to sheet metal product since this is my SolidWorks. I can simply clicking on the edges where I just want to create my bends. Here I am just representing a common sketch where my fixed face should be and concurrently I am choosing the side of my edges to create the bends. The bends created can be easily customizable and editable through the different corner flats with representing the overlap or underlap and the customer bend elements like K factors, bend directions, etc. And the corner reliefs can also be easily treated with respect to the TR, etc. So here you can able to see within a fraction of minutes I created a solid to a sheet metal part. So that how much of different kinds the glue is the placing of forming tools is very much easy in the creation of tools. Since SolidWorks is a parametric design software, the tools are very much of customizable and the numerical values are easily controllable. Placement of forming such as the punch date is very much of easy. I can easily save my designs in my design library so that the repetitive tasks can be easily reduced. This saves me a lot of time so that I can able to focus on the other areas. The special of SolidWorks tools are as a designer I can focus on the designs but not on the tools. By working on the different kinds of forming tools is very much of easy. Controlling of degrees and flipping of faces, how it should be a positions. Those entities can be easily created and converted so that I am just simply creating a normal lances for this sketch. Placement of embosses is also a easiest thing so that I am just pressing on the edges. So simply I am placing where I just need. How the extruded flanges and normally the drafted places just placing. Here, as I told, the positioning of the forming tools is very much of easy. Normally a library part can be able to save, and instead of the normal part and sketch, I can save as a library part so that I can able to work easily. Suppose I am creating a fill pattern for my face where I just want to reduce my weight of my components, so that I am just creating a seed patterns so that you can able to preview my how it should be cutted parts after my design, so that a preview mode enhances the designs to evaluate your products. The instances can be easily controlled through the removal of instances, and I can place wherever I need. Here you can find within a fraction of seconds I created a fill pattern so that the component's weight has been reduced. As a practical, the following of thumb rule is very much of difficult, so through a SolidWorks designs we can easily achieve in a matter of seconds. Here for my this complicated profile, I can able to calculate my exact blank area. So the corner treatment such as the bends, etc., I can able to create and control easily through different kinds of corners. Here for an example, the break corner options I am using to control my edges through a fillet as well as the chamfers, and those properties can also be easily controlled through a numerical values, that is nothing but my dimensions. I am just keeping my fillet as the 8.5 mm radius to my edges. So within a matter of seconds I can able to create a solid body and converting those solid body into a sheet metal and calculating the black development area. Let me move on to the drawings, how drawings will be more helpful for this much of flattened patterns. A creation of drawings is very much easy. One third of the time takes a design to create drawings. 60% of the drawings were not matching to the model, so that the one third of the US dollars are spending for only the 2D drawings. So in SolidWorks we can able to create a flat pattern so that those drawings can be easily created by picking up the different kinds of sheet formats, and the first and third angle can also be easily worked out depending on line standards. Here the placing of views is very much of easy. I don't want to work hard myself, just picking and placing on the respective locations I need. Scales can be easily controlled as dependency on the C scale as well as the customer scale. Here I just like to change my sheets into my customer scale for 1:2 ratio. Let me see how to create a tables for this kind of patterns. I just like to create a bend table for these patterns. Here instantly I can work on the different kinds of tables and the auto creations. I am here just creating a punch table for this with respect to the x and y coordinates. You can able to see a table automatically created. The meta properties has been updated automatically. The tag number and the locations of the x, y and the angle, how much of degree it has been bent, and how much of quantity is automatically updated, so that the software people can understand very much of easy for the designs and their manufacture. It represents clear understanding about the directions, the angle, and also the inner radius. So instantly I can able to create my drawings whenever I complete my 3D models. and auto update of title block informations, the material which I have been worked, and the weight of my component as well as the cover. I can easily control this by customizing my property whatever I need regarding the models I created. So here you can able to see the created completed model with precise and accurate manner. Let us show you how to convert this flat pattern and give input directly to the operating machines through a DXF or the DWG files. I can easily convert my sheet patterns to directly by DXF DWG files by geometry, the sketches, the bounding balls, etc. If suppose I am in need of necessary only the geometry and the bend lines, also I can easily able to control within the control of the checking box, the checking and uncheck by what are the necessity of my entities to export through a DXF or the DWG files. Here you can able to see the flat patterns alone I have created and the bend lines and the outer boundary lines. So what are the designs we do? A normal sketch, the building blocks into 3D covers. So what are the updates I do in my part model? It reflects into my assembly models. So this is nothing but the associativity. So let me move on to the next. That is how what are the some tools that will be more productive and will be more helpful for the manufacturer peoples to create a complicated fixtures, the complex profiles, corner treatments, and the how indentures will be possible with accurate and precise. Here I am going to show you how a jigsaw fixtures manufacturers will be more helpful through a simple tool through a tab and slot tools. So here this is my model. I am just going to create a simple tab and slot for this much of models to reduce my assembly cost as well as my manufacturing setup cost. Just simply clicking on the edges and faces, I can easily able to create my tabs with respect to the slots on clicking on the faces. Everything is easily customizable and I can also control my spacing lengths. The length of each tab, individual tabs I can easily work, and those tabs can be easily corner treatment has been created, and the height also be controlled through the respect to the slot clearance. I would like to work on the another edges. For an example, here on the right side corner of this part, again I am just creating a tab and slot for this kind of edges. Here this time I am just going to create a 2 instance with the different lengths, that is the controlling variables, and the corner treatment this time I am going to prefer a chamfer. So on the explosion view we can easily be able to view and easily unstable how quickly I can able to create a tab and slot with respect to the edges and the faces I just want to work. What about the creation of the different complex profiles? Like an example, how much of bends should be intended, how much of segments should be created, whatever it may be, I can easily create through a tool, nothing but the lofted bend. This is a specialized tool for working on the different complex profiles. For an example, I just want to control through a segment length. I can easily control the facet values and the sheet metal parameters through a default parameters, nothing but a cap factor, when relevance can also be easily achieved. I can create a number of blends through a 6 facet values, and the K factor will be a standard of 0.45. So instantly you can able to create a different complex profiles. Either it will be a rectangular to the corners or circular like ducting properties. Instantly I can able to flatten those complicated profiles so that I can able to calculate how much of blank area required to create this kind of profiles. So next we are going to see an important and interesting topic, how to estimate easily and how to quote to our new prospects or as the existing customers to receive an order through a sheet metal costings. Sheet metal costing is the most important thing, and how to create an estimation for my work project or to going to be create a new project. It can be costing can be easily done for an assembling setups as well as an individual part setup. It never mind what are the materials I need. The different kinds of classified materials can also be easily worked through a sheet metal costing. The setup cost, the calculated cost, and either a purchased parts can also be easily created as a setup file so that I can able to easily customize my costings. Here I am going to show you how an individual part has been create a costing for all the details has been updated automatically. Costing can be easily created for a sheet metal, a machine components, the castings, the plastic parts. So here I just want to predefine what wants so that the materials and the operation cost, the cutting methods, the thickness of my material I just want to work, and some of the other customized costs such as the overfinishing parts, the anodizing plastic, etc. Also, I can also create a rules-based automation costing through the creation of some of the rules so that I can automate my costings. Here you can able to see the different kinds of class. If suppose I am working on the different alternative materials, I can easily calculate my cost. For an example, instead of stainless steel, I am working on aluminum alloys with the different names. Now, suppose I am for instance 303 alloy. I am just going to work, and I can instantly see what will be the amount when I change the different materials and the different sizes of my sheets. Costing can be easily created for the sheet metal size as well as the weight of my sheets. So also I can able to visually see and calculate my bounding box nesting. How much of my nesting I took to create this kind of complicated profiles. Suppose for an instance I am just changing the sheet size 1.5 into 3 meter. So here what will be my bounding box for this kind of 1.5 into 3 meters sheets. So you can able to see the remaining sheets visually so that I can able to work for the remaining sheets. The assembly cost setup can be easily created through a machine components, as suppose I am buying components can also be easily controlled. Suppose I am working on some amount of percentage markup discounts, easily I can also control what will be the amount if I keep what will be in some amount of percentage. Those working projects can be easily generate a report through a Word file. Here SolidWorks has a capability to store the documents. What are the documents we need to work as a representative documents, easily we can able to connect with the design manager tree. For instance, here I just want to work on the documents, Word document files with either a PDF or image files. What are the documents we need? We have to attach. We can easily create those documents in a design binder. So these are the most beneficiary things for the designers as well as the R&D departments through a sheet metal fabricators will be more helpful through a SolidWorks. Next, we are going to see a great another topic about how to reuse our design and automate using a normal MX for Excel. The added benefit of SolidWorks is there is an interlink between the MS Office and SolidWorks so that we can easily automate our designs through a numerical values so that I don't want to know about the knowledge about codings. I can easily drive my parts and assemblies through the controllable variables with dependency on each other. Next, I am going to see how strength is my product I have designed will it withstand my required load. So this is my working model. I am just going to show you how to simulate and validate my product and how it will react in my real-time environment so that I can evaluate through in my design stage. So this is the cluster model. I am just going to work for you. So here the sheet metal components, how deformation it will affect, how much of load it will withstand. Let me check up through a designs, and also we are going to see about how to optimize our design. So since the load acts concentrates on the ring of this form with respect to the upward directions, the resultant force, so that I am concentrating on this kind of part. I am going to evaluate the sheet metal components whether it will withstand the load of 1280 kg force. The thickness I have created for this design this model, will it really withstand the 1280 kg force of the design thickness. The fixtures can be easily created, how it will be grounded through in my real-time environments, and the external loads such as the force, torque, pressures, the gravity and so on can be easily induced into my model so that I can evaluate my product. For instance, I am just creating a fixture for at the two end sides so that I can able to fix and make enhanced positions of this end position. The load I just want to prefer giving on the ring face since the load concentrates on this area. I can easily prefer the 1880 kg force load acting on the ring to the upward directions. So let me mesh this kind of components and run the analysis. SolidWorks simulation is one of the fastest evaluating and validating products so that the results will be easy and precise, and as well as the accurate results has been established. The stress and the displacement and the factor of safety can also be easily calculated. Here you can able to see the blue color shows that it is a safe load and the red mark shows the severity of the loads. My deflection of the small is 2.202 mm so that the results which match really approximately to the 95% of the real-time results. Factor of safety, usually fabricators keep a 2.5 times of my real-time material. So here my calculated FOS is 7.3 times. So if I need to reduce my thickness of the sheet metal, I can work on the models with dependency on my chart of the right hand side. So here I want to check my deformation, how my deformation acts with respect to the frames I have created. For instance, I just want to create a frame to change from 5 frames to the alternative of 25 frames and want to check how the deformation should be created and what are the loads acting at the most area. Next, I just want to show you how to optimize my design. Really, I'm using to withstand a 1280 kilogram cells. I have used a 38.1 thickness. It is really a reliable thickness for to withstand those 1280 kilogram force. I'm having a question about that so that I can easily evaluate and optimize the design so that I can work on the reliable thickness with respect to the stress and mass. So here I'm just going to work on the keeping a goal of maintaining a mass. So for the 100 thickness, so the stress acting on the 190.3 newton per square, the mass of my product is 78,765 grams. So this the automatically shows this is the optimized design. I can easily calculate my stress, displacement and the factor of safety, how it will react in my real-time environment and how much of impact it will be in that. Those reports can be easily generated through an image. So next we are going to see a summary of our presentations. So obviously the design development cycle times can be easily radically reduced so that the product innovations can be bring up through our ideas and creativity. The time required to change our designs and easily validate within the respective of 90%. So from the building block of sketch and creating those sketches into the 3D model, and those 3D model will how it will be reacting in a real-time environment can also be easily validated through my designs so that I can enter into my market even more faster, the sooner and the better. In case of any queries or any live demo presentations, you can contact us. Aegis Computers India, and the phone and email ID has been given. Thank you.